Hi everybody, welcome to Hydraulic Engineering for the 24th of April. This is class 38, our last class of the semester. A couple of announcements here before we begin. Homework number 11, which is your last homework assignment, it includes a big range of material. It's got hydraulic jumps, it's got underflow gates, it has water surface profiles. Remember that that assignment needs to be uploaded to Blackboard before 11:50 p.m. on Friday the 24th. So please submit that on time, and if you have questions, you can send me an email. Regarding the final exam, we're scheduled to have that on the 1st of May, Friday the 1st of May from 12:45 p.m. until 2:45 p.m. And I've previously described what the procedure is going to be for that test. It's going to be similar to our second midterm exam, where you'll be able to print it out, or you can just solve it on a blank piece of paper, and then you're going to submit with CAM scanner and a PDF file to Blackboard. And then, if it's an Excel file that you're using Excel to solve, obviously you'd upload your Excel solution as well. The parameters of the exam is going to be that you can use your previous homework assignments, you can use the textbook, but you can't collaborate in any way with another person. So, of course, the instructions with the exam will be on the exam itself. So that test is on Friday, the 1st of May. Today we're going to continue talking about the standard step method, and this is a technique that we began on Wednesday. In Wednesday's class we worked the first example, so today we're going to continue with another illustration, another example, and you can use that same template file that I provided earlier, because if you look at the bottom there's a tab for this second example. So let's get into it.
We've got triangular going to a half circle downstream. We know that they're 100 meters apart, the roughness 0.045, and we're putting 1.5 cubic meters per second through there. So I've already calculated the critical depth and the normal depth. All right, that confirms it. That this is subcritical conditions, because if the critical depth is 0.65 and the normal depth is 0.98, then that means we've got a mild slope. And here at location 1, the depth is 1.5. So the question is, what is going to be the depth here where it goes to triangular? So in the template file that I've provided you, we've got basically the same setup, but note here that it's cubic meters per second, z is in meters, length is in meters, and so when you do the g, then be sure that you use 9.81 this time. And just to make things a little bit simpler, let's add that water surface column in again. It was next to the y one, between the y and the a. So if we add a column here in B, we'll call that the water surface at 1. And heck, while we're adding things, we might as well even add a velocity head term, because we'll use that later. So, no, let's not. What would we even call it? All right. So at 1, where we know the conditions, we know the depth, we know the elevation of the channel bottom, so the datum is right at the bottom of the channel there at 1. I'm going to pause and let you work through this one independently without me narrating and interrupting you, but I'll be circulating around with the solution to see if you're on the right track, and then when we've maybe got 5 minutes left, I'll start doing the solution on the screen so you can double check to see if you got it. If you haven't already started with something else, try a depth of 1.5. Just choose the same depth at that upstream location and see what are all the calculations that arise from that for our triangular. All right. So the answer to this second one is that the depth should be 1.26 meters. And I think the tricky thing here is maybe the geometry of the of the half circle and of the triangle. But if you figure that out, it's really the same process as it was before, where I added again a column for the water surface at 1 and the water surface at 2 just to simplify the calculations. So we see that the percent difference is rapidly declining and it's eventually converging on 1.26.